So over here, right, we start with the height calibration, as I was saying. So we took into account a lot of things, such as the height of the table, the height of the platform the robot is sitting on, right? And then that ultimately yields our number for where our first point is going to be, right? And that first point is going to be that center point for that circle that we defined. But basically, this is slightly offset from the table at exactly the layer height that we want to extrude, right? The shape. So to that's the start of our series, right? Because since I'm doing like a radial pattern, I'm using it as the start of the series. If you're doing a series, then that's what you want to use. But in any case, that's your starting point, right? That's the height that your first layer is going to extrude at. So from there, then you define how much we're stepping up, right? So what is the layer height? Every other layer is going to be done at a specific height from that. So right now it's at the 4 millimeters, right? And that's because the nozzle we were using was the 4 millimeter nozzle, right? 4 millimeters in diameter. So we used the same height as the width of the extrusion, right? But what we found worked better later was actually making it squish a little bit, almost to like 3.88, like around there, millimeters, right? So it seems that going a little bit lower on the layer height than what the nozzle diameter is seems to work a bit better in the long run, doing a lot of layers. And then how many layers you're doing, right? Which in this case is 40. So, right? So from there I basically get, right, like all these center points that you see right here, right? That's what this series is yielding. It's like all these center points. So from there, right, the center position. So these points are basically the points that the circles are originating from, and then this is the vase. This is the vase's position. So here we're talking about heights, right? And then here we're talking about distance from the very center of the robot to the location on the table that we're extruding onto, right? So here you see right from the base of the robot to the middle of the table, right? And then from the middle of the table, where on the table did we place the surface that we're extruding onto? And so that becomes our x, right? Our x-axis is always what's in front of the robot, right? Y is sideways on the robot. Within the Rhino like kind of 3D environment. So then here's where we start with our circle variations. So this is what I was talking about. So this range, right, is setting up a value for the offset or the change in sizes of the circles, right? So in this case, our domain starts at 100, right? So the minimum radius that we have for the circle is 100 millimeters. And then it's just an offset of 4 millimeters. So what you're seeing, the curvature that you're seeing here is 4 millimeters plus and then 4 millimeters minus, right? That's really it. And then for the range, it's important that the steps match your amount of layers. But in a series, when you put 40 values, you get 40 values. For some reason, in range, when you put 40 steps, it creates 41 values. So that's why I'm subtracting 1, right, from the amount of layers, because then it yields 40 values. And then this sign graph is simply distributing those values within the domain to a specific configuration for the cylinder. So if I mess with this graph, it's going to be those same values, right, in the domain. They're just kind of arranged differently. So earlier we were seeing it come out and then come back in. Now we're seeing it come in and then come back out, right? So, right, that plugs into the radius. So everything before the circle is really just setting up the position and location, right, of where we're going to be extruding, which all these numbers are going to generally remain the same for whatever it is that we're extruding, right? Except this can be kind of a guide of just how much we can have the design curve and change and everything, but this can vary also from design to design. So now that we have our circles, right, these are each layer, right? So the robot's going to extrude the clay on each one of these layers, right? So from there, we need to set this up as a path for the robot. And the robot takes in a lot of different instructions, but it ultimately, can you plug me in over there? Because I'm not charging over here. Whoops. Table looks plugged in. Thank you. So there's this there's a number of operations that we can use with the robot, right? There's spline, there's line, there's curve, point to point, line, spline, and those are the general ones. So in this case, I'm using the spline tool, right? And I'm doing that because I need to feed it points, right? No matter what operation is, the robot needs to interpret points, right, with an orientation, right? Or in other words, a plane, right? And then it goes from plane to plane, right? So it moves from location and orientation and so on. But it can do so from point to point, so in the most efficient way that it finds. It can do that as a line, so as a straight line from one point to the next. Or it can do so as a spline, so it'll take in the whole operation that it's supposed to do, and then it'll kind of create a curve according to the position of those points. So since I'm working with a circle, if I divide that circle into points that are right in that circle, and then I use a spline, I can be sure that the robot's going to be tracing that circle, rather than, you know, if these are 8 points, instead of doing a circle, if I used the line command, those 8 points would yield an octagon, right, with 8 points. But because it's a spline, it's doing that curvature operation. So those are the points that we're using, right? And so those points are plugging into the spline command, as I explained. And then I'm plugging it into this panel so that I can see the coordinates of that first point it's going to, right? And we did this because at some point our initial height changed. So here I can make sure that the z value here, 391.4, is consistent with, right, 391.4. We can make sure that the first coordinate that it's going to move to is consistent with the height that we set for the first point that it's going to travel to earlier. So that's just to be safe, like double checking. And so then for the spline, it also allows us to set the speed that it moves at, right? So we actually started, I think, at 0.2, and we worked our way, and 0.2 didn't work too bad, but we found that reducing that 0.025 worked pretty well. But there's also a difference with the speeds as far as how much it's layering, right? So the distance of one layer to another and the speed contributes for the thickness of the extrusion. So if they're too close together, the layers are too close together and it's moving too slow, you're going to end up with fatter layers, right? If you think about it like oozing and just kind of like too much coming out into the same place very, very slowly, it's going to widen out, right? Whereas if we raise the layers or we make it move faster, the walls will become narrower, right? So this is just what we found to be most stable, is this speed at a lower height than 4 millimeters. So that's where the points are going, right? This is just a branch viewer. I can go into more into depth into this, but generally right now what I'm just going to explain is I divided the circle into 10 points, right? So then here you have the first circle, right? And it's 10 points, right? This circle becomes a branch, and that branch then contains its 10 points, right? So this darker series here, this branch number 1 is the next circle, right? And it's 10 points, right? So this visualization here is basically all the circles, right, with each one of their points inside, as shown as branches. So if I were to flatten this, I'm eliminating the branches. So now it's just a continuous, right, set of points that it's going to travel to. But in that way, I can't extract the point at which I wanted to change layers at, right? Because now there's no way to identify what layer I'm on. It's just a continuous set of points. So by having it grafted, when I list index 0, right, I'm always pulling that first point of every circle, of every branch. Does that make sense? Yeah? So, right, so there we're setting up our points for each layer, and then we're setting up our safe plane. And we see that right here, right? Those are the points I'm pulling from every single set of circles. So there's our spline with our speed, and now that's fitting into our safe plane, right? So this is the offset that I'm talking about. It's going to take the spline commands, right? And if you notice, they're still grafted, right? So even when they're robot commands, it's separated into each circle as its own command. So if I have 20 circles in the simulation, if I keep it grafted, I'm going to have 20 robots drawing one circle because it's branched, right? It's not flattened. But I want to keep it branched when I'm creating my safe plane, right? Because if I have branches for each circle, then I can insert, right, a safe plane into each one.
So that's why you don't flatten before. First you put the branches there with the safe plane, and then you flatten that, because you're going to create like the ramp in each circle, and then you flatten to one thing.
So by keeping it branched, that's how you're able to combine a layer with an offset with a layer of infill, right? And then the same sort of configuration. And then once you have it all combined how it should be, then you flatten as one continuous set of instructions, right? So here we see that the safe plane, right? Well, the commands are coming from our spline commands, which is just tracing each layer. Our safe plane, right, is coming from this right here, right? All those single points I pulled out. And then there's a different speed that we can set for when it changes layer. So we actually went a little bit slower when changing layers, and that created a seam on the vase, right? I wish we had pictures really handy, but I can show you guys later, where it would draw the circle, and then you can tell that when it starts to change the layer, it thickens up a bit, right? Because it's going a bit slower. We found that it can be beneficial in some circumstances for the extruder to move a bit slower because it adds more stability, but too much variation can create too much inconsistency in the form that then it starts to compromise the shape. That's when we flatten, right? So if we're adding an infill, that needs to be done beforehand. So that flattened command then goes into here. So this is your core command for the robot. This is where ultimately you're going to export the code, and kind of all the pieces need to fit into this one. So our commands, right, is going to be the combination of the spline commands with the safe plane added to it, right? And then we need the tool. So in this case, it's a custom tool, which earlier we had the mesh, right? So that's why we can add a mesh to preview that tool. But then that tool needs to have a specific set of values as far as, and this is all calculated from the flange, right? So if you add a custom tool, you need to tell it where's the position of the contact point on the tool, right? According to the flange. So you can see here that Z would mean straight away from the flange. So what is the distance from the flange to the center of the extruder, right? And then X is downwards from the flange. So how much lower is the extruder point, right, from the flange? Then what type of robot we're using, right? And then any collision geometry that we need to avoid, right? So that way the simulation will give us an error if we collide with anything like that. If we double click here on settings, right, we have advanced settings, right? So we can interpolate movements. What that basically means is that if it's going to trace a whole bunch of points, right, we can tell it, right, go from this point to this point as a curve. Or we can take that operation that we want to do, and instead the robot will say, instead of having from one point to one point, right, and go as a curve, it'll create all those steps on the curve, right? It's not always good to do that. Sometimes it is. It really depends on what it is that you're doing. It can take away precision of where you're trying to, of what you're trying to do, or where you're trying to make the robot move to, but it can add fluidity to the movements, right? So it really is a case-by-case basis. And then here, interpolation, right? So this resolution, that's how spaced out those kind of sequence of points are going to be along the commands that we're giving it, right? Initial posture. So sometimes with this robot it happens a lot where we have it move over here and then we want it to move over here. And for some reason, when it moves over here, this axis will completely turn 180 degrees the other way. and then operate like that a bit, and then turn another 180 degrees. So that's really all about how you're trying to have the robot relate to the positions that it's trying to move to, and you set that with initial posture. Sometimes initial posture can take away issues with the robot colliding with itself. Sometimes it can add those issues. So it's kind of just like a drop-down menu and a search-by-search basis on which initial posture is going to work. Some commands allow you to introduce a specific posture into it, so you can have those settings change according to what command you're using. Right?
Have you changed anything for the other one?
For the script that we had been using, I just changed a few things on the tool, like to make the I changed a few numbers, but it's more accurate now. But we'll find a way to to get those values to you guys if I can't share a script.
Maybe print it or something on the
yeah.
thing we need to, like,
for everybody to have. Yeah. External kinematics. Hopefully we can use this in the future. We do have a 7th axis, so basically a turntable for whatever object we could be using. So that way the robot's moving, but then the object that's editing can also be moving. Or if we ever set up the robot on a rail, hopefully. So this is where you would set those things up. Then here's the code. We're always using KUKA KRL, right? Whatever. Last important thing really is the analysis. So here you can zoom in and out, so you want to make sure that before you export you zoom out all the way so you catch any errors. And let me change the initial posture, see if I can cause any errors. Yeah. So this initial posture is causing an error all along the entire thing. But I can click on the simulation here, right, and see at what point the error is happening. In this case, this posture is giving an error throughout the entire thing. But I can switch that initial posture. Let me see if there's one that gives an error, but not entirely. Okay. I guess it's all goes wrong or it all goes right. Here it's not even understood. No, I already did that one. Why? Yeah, it's strange. Now it's giving an error, but it's not giving me the error position. But in any case, you would get that vertical bar, right, wherever you're getting an error, or if you get any axis turning red, then that means that axis is colliding with itself, with the robot, right? So you want to, that's the purpose of the initial posture, and you always want to check the analysis for the simulation to make sure that it all runs smoothly, right? Yeah, that's not playing it, that's just kind of clicking through the graph, but to play it, you have the simulation slider, so simulation time, you can set it to by seconds, right? So 6 seconds, 30 frames per second. No, this is looping. Disconnect. So frame rate 30 seconds, right? So with this simulation slider plugged into that, we kind of see a whole simulation of how the whole thing's going to work, right? Which is just a bunch of circles in this case. If you're trying to look at a specific point without going into the analysis, you can also add a number slider. The number slider on the script I sent you guys had 4 decimal places, so maybe that was causing an issue, the fact that it was just too much precise data as far as like time. But you can kind of drag and see specific points in the script. So again, when you're getting an error, you can check that error here, or you can also kind of cycle through here and see where that error is happening. Although in this case it's happening everywhere, but when sometimes it's just giving you an error in particular places. So that's a quick rundown of the workflow that we've established for extruding, right? We got pretty successful with peanut butter. I think we were able to do 15 to 20 layers before it's peanut butter, so it just starts collapsing. But I think 15 to 20 layers with that was pretty successful. The clay will be much easier to work with. We have to get it to the right consistency first. So I suspect that we'll probably go too wet first and then work our way to